Select the major product of the following reaction. So if we take a look at our starting material, we see it contains two functional groups. So we can see that we have an amide, and we can also see that we have a ketone. And then we want to see what we're reacting this with. So we are adding in lithium aluminum hydride, and so what this is this is a really powerful reducing agent. And so what we need to assume here is that this is going to react completely with anything it can reduce. So we have it showing just one equivalent of the lithium aluminum hydride. Don't let that fool you, because there's actually 4 nucleophilic hydrides per lithium aluminum hydride molecule. So there's more than enough to reduce both that amide and the ketone. So what we need to know is, what do we form when we reduce amides and ketones? So what I'm going to do here is I'm actually going to redraw the amide and the ketone. I'm going to redraw this entire molecule. And so here's what we need to know. What does lithium aluminum hydride do? So this is also known as LAH. So what does it reduce amides to? So amides, so this is with LAH, amides will actually be reduced to amines. So this is the only time that you're going to see the oxygen of the carbonyl being a leaving group. And that's because the oxygen is more electronegative. It's going to be ultimately a better leaving group than the nitrogen. With a ketone, it will reduce it to an alcohol. And specifically, since it's a ketone and it has 2 bonds to carbon, that would be a secondary alcohol. So if we want to draw the reduction product, we can recognize with the amide that we are just going to reduce off that carbonyl. So there it is. And with the ketone, when you add a hydride, you are going to have added a hydrogen to that carbon atom. And we can draw that in if we want, and also here. And so you can also highlight the hydrogens that were added to the amine. But in the structure, you're not going to see these 3 hydrogens. They're simply understood to be there. So if we take a look, we can see that this is the answer that is corresponding to the structure for B. Okay, so lithium aluminum hydride, the most powerful reducing agent that we see in this chapter. It will reduce every single one of our carbonyl compounds, our carboxylic acids, and carboxylic acid derivatives.